Hey everyone, today we're going to be taking a look at this problem right over here involving matrices and determinants as well as inverse and adjoints of matrices. So it says show that the matrix A 2, -3, 3, 4 satisfies this equation. Also find A inverse. So this is like a two-part problem. We have to first prove it satisfies this equation, then we have to find its inverse. So personally, I like to get the hard part over with. I like to get the provement part over with because usually that takes a few more steps than just finding an inverse of a matrix. And this is a pretty simple problem. It's just a 2x2 matrix, so finding the inverse shouldn't be too difficult. So first, let us prove this part right over here. So let us do the proving part first. So in this case, they're saying that when we substitute the matrix A inside this equation for x, it should be equal to 0. So that's basically saying x equals A, then only this left-hand side will equal this right-hand side. So that's saying x has to be equal to A for the left-hand side to be equal to the right-hand side. And that's what we want, right? It's saying it satisfies this, so that's how we know that the left-hand side has to be equal to the right-hand side. So now we just plug in that matrix into that equation and see if the left-hand side is equal to the right-hand side, aka if the left-hand side is equal to 0. So substituting that in, that's basically saying a squared minus 6a plus 17 is equal to 0. I'm going to break this into two steps. I'm first going to calculate a squared. So calculating a squared, that's just saying 2, -3, 3, 4, and then once again 2, -3, 3, 4, applying the square matrix 2x2 property of matrix multiplication. We get the top to be 4 minus 9, 4 minus 9, which is, I'll just write the answer here, so 4 minus 9 is -5. Then we have 2 times -3, -6, minus 12. -6 minus 12 is -18. Actually, let me redo that. So minus 18. Next, we have 6 plus 12. 6 plus 12, which is positive 18. And then we have -9 plus 16. -9 plus 16, that is 7. So this is equal to a square. So we found a squared. Now we have to find this -6a, and that's pretty straightforward, right? We could say calculating, calculating -6a. That's just saying -6 times the original matrix that they gave us. So this matrix right here. That matrix is what? 2, -3, 3, 4. All right. 2, -3, 3, 4. Multiplying it by every single element. So -6 multiplied by every single element. So that would be -12, 18, -18, -24. So that is equal to -6a. All right. And 17 in this case, it does not have an a attached to it, meaning that it is an identity matrix. It is being multiplied by an identity matrix. So for example, if whenever you have a constant, let's say like -3 in equation or an expression, that's automatically saying in like matrix form, -3 times I. And what is I, you may be asking? It really depends on the order of the matrix, but in this case, we're dealing with the 2x2 matrix in this problem. So I will say I 2 to denote that it is an identity matrix of the square of the order 2. That would be 1, 0, 0, 1. That is the identity matrix. So in this case, we're saying 17, right? 17 is also equal to, let me just make more space over here. 17 is also equal to 17i, and in this case, we're talking about the square matrix of the second order. So it's going to be I subscript 2, which is equal to 17, 1, 0, 0, 1. So in this case, we can further simplify this, right? Because it's just a constant multiplied by a matrix, just like we did in -6a, right? That was also a constant multiplied by a matrix. That is 17, 0, 0, 17. So this over here is 17. So we have our let's see, we have our 3 parts actually. So we have 17i, we have a squared, and we have negative 6a. Now we just have to add them all up. All right, so we basically just need to solve this now. So these are all square matrices of the order 2, so it should be really easy to solve this. We have minus 5, minus 12, and then 17, that's 0. Minus 18, 18, that is also 0. 18, negative 18 plus 0, that is also 0. I think you see a pattern. 7 minus 24 plus 17 was 0. And that is a null matrix, and that is just going to be equal to 0. So the left-hand side is proved to the right-hand side for sure. But that wasn't the only part of the problem we were asked. We were asked to find the inverse of a matrix, and that was the inverse of this matrix right over here. All right, so finding the inverse of this square matrix. So for those of you who don't know how to find an inverse of a matrix is just 1 over the determinant times the adjoint of a matrix. And I'm not going to go too depth into how to find determinants and adjoints, but I'm just going to explain how you can find the inverse. So for finding the inverse of matrix A, we have to find the determinant first, of course. We have to find both the determinant and the adjacent. So the determinant is simply going to be 4 times 2 minus 3 times 3. And that is just 8 minus 9. That is 8 plus 9, which is 17. So the determinant is 17. So that's one hurdle out of the way. Now we have to explain how to find an adjoint. So an adjoint is, let me remove this right over here. Actually, let's keep it here. So an adjoint of a matrix is nothing but the cofactors of that matrix transposed. So in order to find cofactors, I'm hoping you already know how to find cofactors because I'm just going to write the cofactors down here as well as say it to you guys while I'm writing it down. So for C11, so this is C11, we have to find for A11, which the cofactor of A11 is C11. That's how we denote it. For A11, we are saying that will be 1 times 4. Next will be negative 1, times 3. And the next one would be negative 1 times negative 3. And then the last one would be 1 times 2. And we can simplify this, saying this is 4, negative 3, 3, 2. Yes, there's a lot of matrices in this problem, even though we were just given one matrix. But here we have 4, negative 3, 3, 2. Now we have, this is not just supposed to be a joint, it's a joint of which matrix? The A matrix. So don't just write a joint, you have to specify which matrix you're taking the adjoint of. So we have the adjoint of A. Now we can just plug it back into this inverse formula, saying that 1 over the determinant is 1 over 17. Times the adjoint of this matrix, which is 4, negative 3, negative 3, 2. But that seems to be the end of the problem. We were able to satisfy this condition, saying that the left-hand side is equal to the right-hand side. And we were also able to find the inverse of this square matrix of order 2.